0. Liftoff. Liftoff. All right, liftoff, and the clock is started.
Godspeed, John Glenn.
For the eyes of the world now look into space, to the moon, and to the planets beyond. We choose to go to the moon in this decade and do the other thing.
That's one small step for man. Советский Союз.
Hello from the children of planet Earth.
Our progress in space, taking giant steps for all mankind, is a tribute to American teamwork and excellence.
Liftoff. Liftoff.
In the ignition, and we have liftoff. History's largest astronaut crew is on its way.
Spaceplan 3 is airborne and has cleared the tower.
Liftoff of Space Shuttle Discovery.
I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow. And I expect to be around to see it.
That drive to reach higher is alive and well in today's astronauts, who will travel aboard American-made commercial vehicles to the International Space Station and aboard Orion on our very challenging path to Mars, and getting ready to take the next giant leap for humankind.
Good afternoon, everyone. I'm Dennis Woodfork II, your Master of Ceremonies for today's event, and I would like to welcome you to the 2014 Agency Honor Awards program. This annual awards ceremony is an opportunity for us to come together to honor NASA's best of the best. Before we begin, please rise for the presentation of the colors by Military District of Washington's Joint Armed Forces Color Guard, and remain standing during the performance of the National Anthem by Berry Elementary 4th grader, Miss Ajaya Thomas.
Mars! Ho! Ho! Please, ho!
Oh, say, can you see by the dawn's early light what so proudly we held at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rockets were clear, the bombs bursting in air gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the brave?
Oh. Please be seated.
Ready, stop.
Please be seated. I would like to extend our appreciation to the Military District of Washington's Joint Armed Forces Color Guard and Ms. Ajaya Thomas for her outstanding performance. Let's give them both a round of applause. At this time, I would like to invite our administrator, Mr. Charlie Bolden, to the stage to say a few words.
Thank you very much, Dennis. Let me ask you all to just give another round of applause for Ajaya Thomas for the beautiful rendition of the national anthem. Ajaya, you probably don't know it, but you know, your performance should remind all of us that while STEM stands for science, technology, engineering, and math, what you added was an A for the arts. And when you add that in, it transforms into STEAM. Some of you know I'm a big STEAM person. So thank you very much. The arts transforms us as a people. So thank you for the reminder of the power to remind us of humanity as we explore our universe. And I think that's really special today because we choose to honor not programs or things, but the people who have made them all possible. So thank you again. I cannot go any farther without reminding some of you, but letting others of you know, when I look at Ajaya and I think about where she's going to be, maybe 10, 15 years from now. The very first time I met our Master of Ceremonies, he was, I think, Dennis, were you Ajaya's age, or were you like, yeah. We were on an airplane going from Washington, D.C. back home to Houston, Texas, or something like that. And I met this incredible young man who, much like Ajaya, had the courage to get up and, you know, talk about himself and his aspirations and the like. And who knew that years later I would be working with him here at NASA headquarters. So Ajaya, I expect that you won't be working with me, but you'll be working with some future NASA administrator when you come back to narrate, to be the Master of Ceremonies at this exercise. I also want to welcome, I think we have STEM student representatives from McKinley Technology and Anacostia High Schools here in D.C., as well as Central High School in Prince George's County, Maryland. Are you all here? If you would, just stand. Don't raise your hand. Stand so we can applaud. Thank you very much. Thanks also to our STEM ambassadors here from the University of Missouri, Hampton University, Virginia State University, and George Washington. Are you all here in the audience? Are you? Ah, they are. They're back all the way in the back. That's all right. For me, this looks like Old Home Week. It is so great to see many of you return who have served the nation and particularly NASA so well. You know, this is a really small way to show you the appreciation that we have for all that you did, but we're glad that you could find time in what I imagine for you all is a very busy time of your lives to come back and celebrate with us. We appreciate the enthusiasm and the energy of all those young people that we've introduced in helping us and others to follow in their footsteps. We're going to need all of you to achieve the great things that NASA has planned on its journey to Mars, as well as reach the ambitious goals the entire aerospace field is working on to help us reach higher in the coming decades. Before we get started, I also want to thank several of the hardworking people at our NASA Shared Services Center who have helped to make this ceremony possible. First, Colleen Canary, who has been organizing the agency ceremony since 2010 and takes care of the innumerable details that requires. She also coordinates the selection process, so all of our celebrants today should be very grateful to her for that. Thank you, Colleen. She is here inside. Thank you, Colleen. Thanks for your continued dedication to making this important ceremony so meaningful to everyone involved. I also want to thank, and some of them may be outside still, but I also want to thank Tiffany Mitchell, Elizabeth Edwards, and Daryl Rouse, who have done a lot of behind-the-scenes work to support this ceremony, from the logistics of just getting things here to coordinating the entire event. Their help has been invaluable. And are they out there? Just yell, tell them we said thanks. I want to express my appreciation to today's honor award winners and to the entire NASA workforce for your outstanding contribution to America's space program. This year, we learned that for the second year in a row, NASA was named the best place to work in government. That's a tribute to all the men and women who work here and to our contractor partners who work alongside us every single day as we take America's next giant leap in space with planned human missions to an asteroid and to Mars. At today's ceremony, we will present the highest honors we bestow on our workforce, the Distinguished Service Medal and the Distinguished Public Service Medal. These recipients today have dedicated a significant portion of their careers to making sure our nation reaches the high goals that NASA is called upon to make reality. They represent a commitment to the specific area of expertise that has advanced our missions and made it possible to do the impossible. As we celebrate their excellence, we celebrate all of NASA and the grand challenges our agency meets, which give rise to such passion and talent. We are all the better for these distinguished public servants' efforts. On behalf of the agency, I congratulate them all and look forward to the continuing results of their innovation and hard work. Before we hand out the awards, I want to introduce our guest speaker, a gentleman who represents the innovation and forward thinking that we do at NASA. Bill Barucki has worked at NASA for more than 50 years. From 1962 through 1972, he conducted laboratory and theoretical studies of the radiation environment of entry vehicles. He developed spectroscopic instrumentation to determine the plasma properties of hypervelocity shock waves, and the results were used in the design of the heat shields for the Apollo missions. Bill has long been interested in planets and other solar systems. He has studied the effects of lightning in other planetary atmospheres and has authored papers about how to observe planets orbiting other stars. Ultimately, Bill's dream to observe planets and other solar systems came about with the launch of the Kepler Observatory in 2007. He's smiling down there because he's a happy guy. That mission, for which he serves as principal investigator, has been a smashing success. To date, out of more than 4,200 planet candidates observed by Kepler, scientists have confirmed nearly 1,000. These planets include many different types, including those near the size of Earth, in that tantalizing habitable zone where we orbit, where life could be possible. Bill has a fascinating career, fueled by multiple STEM degrees in physics and meteorology. His work points to one of our key focuses in the future, the search for life elsewhere. Please help me welcome NASA scientist Bill Barucki.
It's a privilege to be here with you as these many people receive their awards. It's also an opportunity to talk about the Kepler mission. The Kepler mission is, in some sense, a step in our exploration of our galaxy. It's basically to determine the frequency of Earth-sized planets in the habitable zone of stars like the Sun throughout our galaxy. If we find many such, there's probably life throughout our galaxy. If we find few such, we may be the only extant life. So I will tell you a little bit about that mission today. Could I have the next slide, please? I always like to start out and show people what the formation of a planetary system looks like. Basically, we know the galaxy has giant molecular clouds, and these clouds are dust and gas, and sometimes they get disturbed by a supernova or something like that, and part of that cloud collapses under gravity, spins up into a flat disk of dust and gas. That dust and gas produces the planet and the star. The explanation, the disk is the explanation for why all the planets go around in the same direction, why the spin axis of the star is perpendicular to the plane, and why all these planets are in that plane. We also use it to explain why We have the refractory planets, the planets that are made of rocks, Mercury, Venus, Earth, and Mars, close to our sun. The thought is, well, they were forming near our sun, and consequently the only thing that could condense out with those high temperatures was rocky materials. So naturally, we would find these rocky planets close to our star. Further out, where the orbit's much larger, there's more material to accrete to build a big planet. That planet gets big quickly, attracts the hydrogen helium from that dust and gas disk. It becomes a giant planet. And that's pretty much what we find, with the exception we find these giant planets not where we find Jupiter necessarily, but all over. And so what that's telling us, in fact, is that if you find them close to the star or near the orbit of Mercury or Earth, they move. These planets move in the formation of the planetary systems. So that's a new aspect that we learned about in our own planetary, that tells about our own planetary system as well. Next figure, please. As Dr. Bolden has mentioned, is that we have found some 4,200 planetary candidates. Signals that really tell us we have a planet, but we always want to confirm them. Do some ground-based work with large telescopes, mathematical work with the signals themselves to be sure that it's not a small star crossing a large star or double star, something like that. And what we're showing now is a group of planets from that group of confirmed planets. And for scale, we have on the second row, you can see Jupiter, the biggest planet in our planetary system, and then there's Neptune down there, and right at the bottom is Earth. The thing to notice is there's a lot of planets bigger than Jupiter. Now, people knew early on that there wouldn't be any planets bigger than Jupiter, because if you took Jupiter and you added mass to it, it would get denser. After all, Jupiter's the size of a small star. That's not what happens. They do inflate a little bit if they're close to the star, but these have inflated much more than that. And so theoreticians are having a wonderful time trying to come up with explanations for such planets. Some of those planets have a density less than that of water, have density, in fact, that of a styrofoam coffee cup, and that's hard to explain. Let's go on to the next slide, please. And what we have here is a collection of all these different planetary candidates and confirmed planets, and we have at the bottom axis the orbital period from 1 day out to 100,000 days. The vertical axis is how big are those planets. And the 1 bar is at Earth, 4 at Neptune, and 11 at Jupiter. The contribution from Kepler is in yellow. You can see a huge number of objects here, and you'll notice that most of them are between the size of Neptune and the size of Earth, and actually quite a few less than the size of Earth. We find planets Earth-size, Mars-size, Venus-size, even some down as small as the Moon. I think we'd find even more, but those small planets get lost in the noise. We are still working to dig some of them out. The blue are planets that have been found with another technique. Instead of the photometric technique, the radial velocity technique. The photometric technique looks for planets to cross their stars, and that dimming that occurs tells us about the size and the orbital period when it repeats. The radial velocity people are looking at the motion of the star, and they use that to find, in particular, long orbit planets. They've been operating for about 25 years, and you can see they find planets out with orbital periods of many years, and they tend to find the bigger planets. The red dots there, I don't know if you can notice them or not, are another technique that we use, and that is we look with telescopes at the center of our galaxy, which is just crowded with stars. And that light, as it comes toward us, passes the red dwarfs in our galaxy. Our galaxies may be half of these small red dim stars. And we can't see them generally, but the light passes over them and is focused down into our telescope. And so we see, when those things align, the signal from the faraway star brighten up and then dim over a period of days and weeks. And we look for little glitches. Those little glitches on that curve tell us about the planets that orbit those stars. So several different techniques being used here to find all these planets. Next figure. Well, science is also about numbers. We need to know the numbers. The numbers allow us to develop the theories that really represent our reality. And here are numbers. Earth-sized planets, almost 700 that we have found. This was as of November. We found even more since then. almost 1,100 super Earth size, up to twice the size of Earth. And those two categories are very, very important. They're the planets that are very likely to be like the Earth in the sense they're rocky planets. They have a surface you might walk upon. As the planets get bigger, Neptune size and larger, you're talking about planets with much more massive atmospheres, much higher pressures, and systems that may not have solid surface. They may be more like the gas giants, like Jupiter. Jupiter is a planet where, in fact, if you threw something small in, a brick, the Earth, it would just drop right on through. Except, of course, Jupiter is so hot that anything dropped into it would evaporate. So it's a very different kind of planet than we're thinking about when we think about Earth-sized planets. Notice that when we get to Jupiter-sized planets, there are very few of them. And yet they're the easiest kinds of planets for us to find. They have a big signal. And so it really tells us for sure there are lots of small planets. But we miss a lot of small planets. We know that, and we can calculate the fraction that we miss. We miss planets that have long orbital periods, like that of the Earth. We don't see enough transits to have the signal come out of the noise. We also miss a lot of planets because for photometry to see a planet, you have to see the planet along its orbit. So the orbit crosses the sun is in your line of sight, so you see that transit, that blocking of the starlight. And that happens randomly. And in fact, you can calculate how often it happens for a given planet at a certain distance. It's the diameter of the star divided by the diameter of the orbit. For short period orbits, 10 days or something like that, that's 10%. You miss 90% of the planets. If you're talking about Earth out at 1 AU, you miss over, your probability of finding it is about 1% or maybe 0.5%. So you're missing 99 out of every 100. But the nice thing is, you know how many you're missing, so you can correct for that bias. And so as we correct for the biases, we can take this measured distribution, this sample distribution, and go and look at the parent distribution that represents what's really out there. Can I have the next figure, please? And this is a chart that one of our team members, Chris Burke, put together for us to tell us, when you correct those biases, what do you find for Earth-sized planets? Now, this is very preliminary. It will certainly change in the coming months and years as we continue to analyze all the Kepler data. But the first thing it shows you is a huge number of Earth-sized planets out there, then super Earth-sized planets and smaller planets. If you look at that left axis is say, how many planets per star? 0.5, 50%. 20% of planets may be twice the size of Earth. So if you sum those together, it's saying most stars have small planets. Most stars, but they're not necessarily in the habitable zone. So there are a lot of Earths out there. Let's look at some of the planets that Kepler has found, because they're really a very strange and very varied lot. And in particular, we're going to look at the planets that are most easily found. Those are the ones that show us lots of transits, but they're very close to their star and thus very hot. Next figure, please. Here's an object orbiting its star. Its year is 16 hours. So it's spinning about that star. It's very close to its star. And because it's close, it's at a very high temperature, 2300 Kelvin. Now, that's hot. That's really hot. If you said, what's the temperature of molten lava on the Earth? Oh, 1600, 1700. How about molten iron, 1850? This is hotter than that. This object is evaporating. And we don't see the object, we see the trail of all the material flowing off that object. Its lifetime, 1/E of lifetime, is about 200 million years. So it's just disappearing before our very eyes. Next figure. This is a planet about 1.5 times the size of the Earth. Again, in a short period orbit, very, very hot. But this planet, we get its size from photometry, the dimming of the star, but we also, because it's massive, can measure with the radial velocity technique, the movement of the star, its mass. If you got the size, you got the mass, you can get the density. The density of this object is 5.8 grams per cubic centimeter. Water is 1. Earth is 5.5. So this is denser than Earth. It probably has a heavier iron core in a silicate rock cover. But the temperature is some 1800 Kelvin, I believe. Is that the number there? Very hot. So it's hotter than, well, it's probably got a molten lava ocean that faces its star. Again, no life. Let's look at other planets. One of the questions we've had is double stars. You know, when you were a child, you probably wished upon a star. Well, about 50% of the stars that you wish upon are actually binary stars. A few of those are trinary stars. And so the question is, with all those binary stars out there, do they have planets too? Theory said at first no. The movement of the two stars would inject momentum into that planet, and the planet would be ejected from the planetary system. That's not what theory says today, and it's certainly not what we find. Here's an example of a planet that we found orbiting a double star system. Is it Luke Skywalker's home? Well, you know, if you look at the temperature, minus 125 Fahrenheit, colder than the Antarctic, the answer is this is not a great place to farm. So, no. So we have to keep looking. Next figure. So here's another double star. This double star has two planets orbiting it, one of which is in the habitable zone. This is the large planet there. Unfortunately, although it's in the habitable zone, it's too large. It's bigger than Neptune. So it's not a rocky planet, and so this is not his home. On the other hand, planets this big can have big moons. Any moon of a planet in the habitable zone is also in the habitable zone. Moons like Titan have big atmospheres, strong, thick atmospheres. Maybe the moon is as big as the Earth. Maybe we found Pandora. But actually, we haven't found any moons. We've looked for moons around these planets. We've picked up signals that we thought were moons, but we haven't been able to prove any of those were actually moons. But we continue to look. Let's go on and find something smaller. We need something closer to the size of the Earth. This is Kepler 22. It's a planet 2.4 times the size of the Earth. Now that's interesting. It's not Earth-sized. It's not Neptune-sized. It's unlike any planet in our solar system. There is no analog in our solar system to this planet. Is it rocky? Probably not. Is it like Neptune? Probably not. Theorists say what we might be finding here, and we find a lot of these, are water planets. Planets composed mostly of water and ices at high pressure, and the ocean would be hot. It would have maybe a steam atmosphere. Luke Skywalker probably doesn't live here either. But could it have life? Well, the temperature may be, close to boiling. But we know that in our own oceans, the deep sea vents have temperatures well over boiling, and there's lots of life that likes those hot temperatures. So this may be an ocean with life, with little creatures and big creatures that eat little creatures. Little creatures generally don't like that. So when they see a predator, they try to jump out of the water, like our fish do. In our own oceans, we have flying fish. Maybe they have fish that have evolved into birds. We don't know, but we need people to generate missions to go and find out, are there fish on this planet? Let's go on. Well, we need to find planets close to the size of the Earth, and we are finding them, and lots of them. Here are two planets called Kepler 62e and F, and we have this green zone. The green zone represents the region around a star where the temperature would be cool enough so you could have water on the surface of a rocky planet. It's actually a measure of the solar flux, the heating to that area. And the green area to the top is smaller than the area in the bottom, which represents our solar system. And that's because the star that we're talking about is smaller. It's about 2/3 the size of our sun. So you have to cozy up to that star to be warm enough to be in the habitable zone. But there are two planets. The outer two, 1.4, 1.7 times the size of the Earth, in the habitable zone of a star somewhat similar to our own star. So certainly a possibility of life. But do we know there's life there? We don't know with Kepler that it has an atmosphere, that it has an ocean, much less life. Kepler was a discovery mission. Go out and find out, are there lots of Earths? And we are finding that out, but there's still a lot to do in the future to get answers about life on these planets. Those planets are still a little bit large, so let's find an Earth-sized planet. Next figure, please. Here again, we have this green zone, but very tiny compared to the green zone, the habitable zone around our own sun. And this is because the star is about half the size of our sun, but it does have a planet the size of the Earth, indistinguishable from the size of the Earth, in the habitable zone. And so again, does it have life? We simply don't know the answer to that. It will be basically left for future generations, for the young people, to go and build those missions and find those answers. Could I have the next figure, please? So let's summarize what we've learned here. Most stars have planets. Earth-sized planets are common. Planets are being found, many planets in the habitable zone, but we've not yet found an Earth-sized planet in the habitable zone of a star identical to the Sun. We still have work to do. But if you put all the numbers together, what does that tell us? We know there's 300 billion stars in our galaxy. A fraction of those are Sun-like, a fraction of those have planets, a fraction are Earth-sized, a fraction are habitable zone. But the numbers come out to be of the order of 1 billion. 1 billion. 1 billion planets about the size of the Earth in the habitable zone of stars like the Sun. We've made our first step in the exploration of our galaxy. There's a lot out there to find. But we have a long way to go. Do the planets have atmospheres? Do they have water and CO2 in those atmospheres? Water and CO2 are what plants need to live, what life needs. And those plants, of course, can generate oxygen for animals. Is there life on those planets? Is there intelligent life on the 1 billion planets? To me, it leads to the big question, and that is, why hasn't SETI heard anything from anybody? 1 billion planets? Silence. They monitor tens of millions of channels for decades. We haven't heard anything. What does that mean? It might mean that somehow there's a new communication system, a new physical process that we know nothing about, that we'll have to discover. It might mean that it's very difficult for life to arise anywhere. We're unusual. Life may exist in very few places in our galaxy. It might mean that. It might mean the opposite, that it's easy for life to start. We might find it Mars and Titan and Enceladus and all sorts of places. But it doesn't evolve to intelligent life. Maybe it means there's intelligent life and people evolve to that point, but then a catastrophe occurs. They're near a supernova and that sterilizes it. An asteroid strikes. Possibly they themselves are unstable and get into a nuclear war or biological war. We don't know the answer, but we would sure like to. So let me summarize finally with the next figure. This is a poem that was sent to us, to the Kepler project, by a fan, Ray Goodwin. Somewhere there are mountains glistening in the snow. Somewhere there are mountains that we shall never know. Somewhere there are rivers flowing fast and free. Somewhere there are rivers that we can never see. Somewhere there are oceans and sun-drenched island sands. Forests full of creatures in vastly distant lands. Somewhere there's a planet beneath an alien star. The people watch our tiny sun and wonder where we are. One day, perhaps we'll find them across the void of space. Perhaps through ways as yet not known, we'll meet them face to face. Thank you and congratulations on your well-deserved awards.
Thank you, Mr. Barucki, for that sensational presentation. We're truly fortunate to have you here with us today. Thank you very much. Mr. Bold and Mr. Lightfoot, will you please join me on stage for the presentation of NASA's most distinguished honors? Ladies and gentlemen, each year, NASA recognizes individuals who have made a profound impact on NASA's mission success. These individuals have been selected to receive one of two prestigious awards. These are NASA's highest form of recognition that are awarded to both government employees or non-government individuals who, by distinguished service, ability, or vision, have personally contributed to NASA's advancement of United States interests. The individual's achievement or contribution must demonstrate a level of excellence that has made a profound or indelible impact on NASA's mission success. And therefore, the contribution is so extraordinary that other forms of recognition by NASA would be inadequate. First, the Distinguished Service Medal. Today, we honor 23 in this category. Dr. Bruce E. Anderson is being honored for sustained distinguished service, leadership, and technical excellence within the research aviation community, advancing understanding in earth, science, and aeronautics. Dr. Anderson's 24-year career at NASA has distinguished him as a respected researcher and leader of suborbital missions for atmospheric aerosol characterization, as well as experimental advances to quantify aircraft engine emissions. Currently, he serves as project scientist and principal investigator for aircraft emissions characterization studies for numerous experiments and studies. Widely respected for his exceptional leadership and technical contribution over the past 2 decades, Dr. Anderson has advanced our knowledge and understanding in aviation, air quality, and climate. Miss Julie M. Baker is being honored for exemplary leadership, long-standing dedication, high standards of conduct, and infectious enthusiasm in managing Goddard's budget and finances effectively and efficiently. In 1978, Ms. Baker began her career in NASA's International Affairs Office at headquarters. In 2010, Ms. Baker was appointed Chief Financial Officer for Goddard Space Flight Center, where she implements a rigorous financial program to ensure the financial health and well-being of the center's numerous projects and programs. Throughout her 35 years at NASA, Ms. Baker has utilized her astute knowledge of the federal budget process, commitment to cost-benefit thinking, and dynamic leadership to showcase unprecedented stewardship of NASA's resources. Dr. James J. Bock, who could not be with us today, is being honored for extraordinary accomplishments in cosmology, including development and application of new detector technology, leading to dramatic advances in our knowledge of the universe. An experimental astrophysicist and cosmologist for several decades, Dr. Bock has made profound contributions to several important scientific breakthroughs, including ultra-sensitive, low-temperature detectors for imaging the cosmic microwave background, or CMB. Earlier this year, Dr. Bock and his colleagues made a stunning announcement of the detection of primordial gravitational waves through their unique signature on the polarization of CMB, which provided strong support to the theory of cosmic inflation in the very early universe. His new generation of ground-based and suborbital CMB experiments have played key roles in the NASA Antarctic Balloon Experiment, European Space Agency and NASA Planck Surveyor, and ESA NASA Herschel Space Observatory. Dr. Thomas F. Brooks is being honored for sustained outstanding contributions to the science of the reduction of aerodynamic noise in the community. Dr. Brooks has dedicated 40 years of service to NASA Langley Research Center in the discipline of aeroacoustics, the study of noise generation by airflow. His pioneering efforts aimed at constraining unwanted aircraft noise within the airport boundary include work in helicopter rotor and fixed-wing airframe noise reduction. A fellow of the American Institute of Aeronautics and Astronautics, or AIAA, as well as the American Helicopter Society, or AHS. He holds 4 patents, served as a mentor for junior engineers and researchers, was awarded the prestigious AIAA Aeroacoustics Award, and participated in teams that won the AHS Howard Hughes Award. Dr. Brooks's investigation, research, and technical excellence have contributed significantly to the pursuit of NASA's mission reduction to reduce aircraft noise. Major General Lynn Collier is being honored for distinguished service characterized by unusual initiative in leading partnership efforts to make Marshall Space Flight Center and Redstone Arsenal a more effective and efficient federal city. For over 26 years, Major General retired Collier has served the federal government, culminating with his service as the commander for Redstone Arsenal, the Department of Defense installation that hosts Marshall Space Flight Center. To improve the quality of life on site, he led a comprehensive effort across the arsenal and the local community, mobilized support, re-energized the Community Relations Committee, and addressed important local health care and education issues. Through his innovative service and leadership, he has enhanced the center's ability to tailor future airfield enhancements, reduce costs, and improved efficiency in joint 911 emergency and ambulance services, and set the stage for future improvements. Ms. Olga Dominguez is being honored for her career of extraordinary contributions, distinguished service, and outstanding leadership in support of the nation's space program and NASA's mission. Ms. Dominguez served as the agency's lead for executive leadership, policy, technical expertise, and oversight of NASA infrastructure and management systems for construction of facilities, aircraft, environmental, real property, logistics, and strategic capabilities programs. Most notably, as Assistant Administrator for Strategic Infrastructure, she effectively implemented NASA's continuous risk management requirements at the institutional level. Her vision and effort was a paradigm shifting, and her leadership on environmental management issues have led NASA to prominence among federal agencies for sustainable practices. While citing only a fraction of Ms. Dominguez's accomplishments, her contributions to the nation's space program and her leadership at NASA have been nothing short of distinguished. Ms. Lelia B. Garver is being honored for distinguished service, remarkable leadership, and great vision in support of the nation's space program and NASA's mission. Nominated by President Barack Obama and confirmed by the U.S. Senate, Ms. Garver began her duties as NASA's Deputy Administrator in July 2009, serving 4 years as the second in command to provide overall leadership, planning, and policy direction for the agency. During her time as Deputy Administrator, she held numerous senior positions in space policy, was a member of the NASA Advisory Council, a guest lecturer at the International Space University, President of Women in Aerospace, and President of the American Astronautical Society. Ms. Garver's contributions in support of human space exploration, technology development, earth science, and aeronautics research decisively enabled NASA missions. Dr. James E. Hansen, who could not be with us here today, is being honored for achievement and exceptional service in support of NASA's mission and vision for the future. Serving as director of NASA's Goddard Institute for Space Studies from 1981 to 2013, Dr. Hansen was the longest-serving director in the Institute's history. His early research used telescopic observations of Venus to extract detailed information on the physical properties of the cloud and haze particles that veil Venus. His later studies focused on computer simulation of Earth's climate, working to understand the climate system and the human impacts on the global climate. In addition to his numerous worldwide awards and recognitions, Dr. Hansen authored Storms of My Grandchildren and serves as the adjunct professor for Earth and Environmental Sciences at the Columbia University's Earth Institute. Ms. Lori N. Hansen, who also could not be with us here today, is being honored for distinguished strategic leadership and sustaining engineering contributions vital to the success of NASA's programs and Johnson Space Center's achievement of agency objectives. During her 30-year career, Ms. Hansen has demonstrated distinguished innovative technical ability and influential consensus building in key management roles, including Deputy Manager of the International Space Station Program Office, Deputy Director of Engineering, and Director of Safety, Reliability, and Quality Assurance for the Constellation Program. Ms. Hansen exemplifies NASA's core values by embracing forward thinking as she continuously strives to develop safe and cost-effective engineering solutions. Dr. James R. Irons is being honored for distinguished service to NASA's Earth science displayed by his tireless leadership, wisdom, and guidance of the Landsat program and the Landsat Data Continuity Mission, or LDCM project. With more than 20 years of pioneering contributions to NASA and the Landsat program, Dr. Irons is a well-published and internationally respected scientist. Serving as the co-chair of the United States Geological Survey NASA Landsat Science Team, his leadership was positively influenced the science and technology contributions of this mission. As a result of Dr. Irons' diligent advocacy for the continual thermal imagery infrared measurements for the LDCM, Landsat 8 is now generating magnificent thermal imagery. Moreover, his contributions among Goddard Space Flight Center, agency, and international partners have created a myriad of multinational initiatives, advanced Earth remote sensing across the globe, and served as the model for future scientific achievements. Mr. Scott Kerr, who could not be with us today, is being honored for sustained distinguished service, dedication, and contributions to NASA and the Kennedy Space Center. With his retirement from Kennedy Space Center, or KSC, in 2013, Mr. Kerr dedicated 25 years to NASA in various leadership positions, including serving in the Senior Executive Service since 1999. His role as Director of Ground Processing at KSC, he provided direction for all flight hardware processing at KSC, and activities and operations as well as maintenance of associated ground systems. In 1995, Mr. Kerr was selected as a NASA Fellow, attending the prestigious Massachusetts Institute of Technology Center for Advanced Engineering Studies. Over the years, Mr. Kerr has left an indelible mark of quality and excellence in his work, always taking time to mentor the next generation of leaders. Furthermore, his visionary leadership and personal caring attention contributed substantially to both KSC and NASA mission success. Ms. Margaret Kiefer is being honored for outstanding, profound, and lasting contributions to the advancement of NASA's mission and the achievement of U.S. national objectives. Ms. Kiefer's professional career, spanning the last 20 years, has revealed a seasoned manager and accomplished leader whose conscientious efforts have made significant contributions to the strategic objectives of both NASA and the nation. Most recently, she assumed the difficult yet distinguished role as NASA's lead official for United Nations matters. Completed revisions to the NASA's procedures establishing the Office of International and Interagency Relations as the agency focal point for tracking of classified interagency agreements, and served as the principal negotiator of the National Space Transportation Policy. With a long record of unfailing leadership in support of critical NASA and national goals, Ms. Kiefer's successful initiatives have improved the integrity of the interagency agreement processes and enabled strategic approaches for key partnerships, thereby strengthening NASA's future direction. Mr. Douglas B. Leviton is being honored for more than 30 years of distinguished service to advance NASA's science and technology goals worldwide by conquering some of the agency's most technical challenges. Beginning his work in 1983 as a lead optics engineer for 3 subsystems for the Cosmic Background Explorer mission, Mr. Leviton's technical knowledge, problem-solving abilities, and creativity helped achieve unprecedented scientific goals. For the last 10 years, Mr. Leviton's technical leadership role on the James Webb Space Telescope's Optical Telescope Element Team has provided unparalleled insight to mitigate risks and successfully solve challenges. With innumerable inventions, publications, and patents, Mr. Levitin has forged a remarkable path in the field of optical engineering, one that will allow NASA to continue achieving project and mission success for years to come. Mr. Leland D. Melvin is being honored for a career of extraordinary contributions, distinguished service, and outstanding leadership in support of the nation's space program, NASA's mission, and STEM education. Throughout his career, Mr. Melvin has been a zealous advocate for promoting innovative approaches in science, technology, engineering, and mathematics, or STEM education, nationally and internationally. His 24-year NASA career began at Langley Research Center, continued in the Astronaut Corps from 1998 to 2009, and progressed in 2010 to leading the agency's Office of Education as the Associate Administrator. As the co-manager of NASA's Educator Astronaut Program, Mr. Melvin traveled across the country, engaging thousands of students and teachers in the excitement of space exploration and inspiring them to pursue STEM careers. He has served the Astronaut Office Space Station Operations Branch and the Robotics Branch of the Astronaut Office. As Associate Administrator for Education, he was also co-chairman of the White House Office of Science and Technology Policy Committee on STEM Education. Mr. Arthur F. Rick Obenchain, who could not be with us today, is being honored for distinguished service and contributions to the Goddard Space Flight Center, enhancing its mission to transform human understanding of Earth and space. With more than 40 years of service to NASA, and in particular dedication to the Goddard Space Flight Center, or GSFC, Mr. Obenchain has provided unprecedented leadership for 60-plus missions. His expertise and technical contributions in aerospace and weather satellite systems have been integral to the success of the Lunar Atmosphere and Dust Environment Explorer, or LADEE, mission, and the Joint Polar Satellite Systems program. Throughout his career, he has delivered, launched, and operated spaceflight systems while helping to develop future leaders and inspire the next generation of space explorers. Dr. John Olson is being honored for the sustained and unwavering commitment to the advancement of the nation's human spaceflight program and strategic planning for international exploration beyond Earth. Dr. Olson joined NASA in 2004, serving in various leadership positions before becoming Director of Strategic Analysis and Integration Division in the Human Exploration and Operations Mission Directorate at NASA headquarters. He directed and integrated NASA's human and robotic exploration activities and led efforts to support retirement of the Space Shuttle and transition to the Constellation program. He envisioned today's human spaceflight strategy, the capability-driven framework, becoming the foundation for global exploration roadmap, now supported by international space agencies. In 2012, he was detailed to serve as the nationally recognized space policy leader at the Office of Science and Technology Policy in the Executive Office of the President, where he was the driving force behind the National Space Transportation Policy and International Human Space Exploration effort. He concurrently supports the Assistant Secretary of Defense for Research and Engineering as a military reservist. Dr. Olson's service to country, commitment, and dedication represents the best of NASA and the nation. Mr. Stephen D. Pearson is being honored for extraordinary and distinguished leadership service in the development of NASA's human spaceflight, science, and technology missions and program. Throughout his 34-year career at NASA, Mr. Pearson has successfully led engineering teams to deliver human-rated spaceflight hardware and contributed profoundly by leading design organizations in the development of state-of-the-art environmental control and life support system for the International Space Station. His contributions to the shuttle program, including diagnosis of critical sensor design flaws, were significant to its success. Most recently, Mr. Pearson's leadership was key in developing the fast, affordable science and technology satellite, NASA's first mini satellite. He and his body of work continue to represent the best in NASA's senior leadership team, making lasting contributions for the nation's space program. Dr. Michael Ryschkewitsch, who could not be with us here today, is being honored for sustained and exemplary contribution to NASA's leadership, engineering missions, and programs. Dr. Ryschkewitsch has been an incredible asset to NASA for over 30 years. His leadership as the agency's chief engineer provided commendable oversight to the review and technical readiness of all NASA programs, including the Hubble Space Telescope, the James Webb Space Telescope, the Lunar Reconnaissance Orbiter mission, and the Cosmic Background Explorer mission. He made significant contributions to the creation of the NASA Engineering Safety Center, and the depth and breadth of his notable efforts richly deserve this prestigious recognition. Dr. Lelia Vann, who also could not be with us here today, is being honored for a career of extraordinary contributions, distinguished service, and outstanding leadership in support of the nation's science program and NASA missions. During Dr. Vann's 32 years at NASA, she's distinguished herself in the leadership of several important missions of scientific discovery, such as the Clouds and the Earth's Radiant Energy System Experiment, the Cloud Aerosol LiDAR and Infrared Pathfinder Satellite Observation Mission, the sounding of the atmosphere using broadband emission radiometry instrument, and the deriving information on surface conditions from column and vertically resolved observations relative to the Air Quality Earth Venture airborne mission. Dr. Vann's sustained scientific contributions continue to provide key information for climate studies, thereby advancing NASA and the nation's science programs. Dr. Richard Vondrock, who also cannot be with us here today, is being honored for extraordinary career achievements in accomplishing NASA's mission, advancing scientific knowledge, and developing the next generation of NASA scientists and leaders. In his more than 40 years as a space scientist, Dr. Vondrock has been a key leader at NASA, exemplifying a remarkable record of sustained performance and exceptional achievement. Throughout his career, he has produced more than 100 peer-reviewed publications, as well as advocated for and implemented numerous interagency partnerships and student outreach activities. His career achievements exemplify the highest agency values and have made a profound impact on NASA's mission success. Ms. Myron Webb, who also could not be with us here today, is being honored for a career of extraordinary contributions, distinguished service, and outstanding leadership in sharing and shaping the story of Stennis Space Center and NASA. During her 28-year career with NASA, Ms. Webb enhanced the recognition and prominence of the John C. Stennis Space Center, or SSC, as NASA's premier rocket engine tech complex, one-of-a-kind federal city, and major economic asset on local, state, and national levels. Her high-caliber contributions paved the way to build the Infinity Science Center, advancing NASA's education mission for generations to come. Dr. Woodrow Whitlow, Jr. is being honored for a career of extraordinary contributions, distinguished service, and outstanding leadership in support of the nation's space program and NASA's mission. Upon his retirement in August 2013, Dr. Whitlow served NASA for 34 years, beginning his professional career as a research scientist and concluding with his work as the Associate Administrator for Mission Support at NASA headquarters, where he is credited with streamlining NASA missions by realigning the agency's workforce and infrastructure. With a PhD in Aeronautics and Astronautics from the Massachusetts Institute of Technology, Dr. Whitlow received numerous awards and accolades for his leadership. He has written nearly 40 technical papers, most in the areas of unstudied transonic flow and aeroelasticity. As a fellow of the American Institute of Aeronautics and Astronautics his commitment to the scientific excellence and outstanding leadership left an indelible mark at NASA. Brigadier General retired Michael Woolley is being honored for his distinguished services to the nation's space program as NASA General Counsel and to the many who are equally proud and honored to have served with him. With his decade-long leadership of the NASA legal team, General Woolley transformed the legal practice at headquarters and throughout the agency. In particular, he helped 3 NASA administrators navigate complex and sensitive issues, giving critical stewardship to the legal challenges associated with the expansion of NASA's traditional focus on the acquisition and program management to embrace new and challenging roles as the commercial space customer and partner. General Woolley also provided invaluable counsel through the space shuttle retirement and post-shuttle era with special focus in workforce contraction issues, contractor pension funding, disposition of orbiters, and transition of Kennedy Space Center to a multi-user complex. Along with his incisive legal expertise, he established a robust acquisition integrity program and automated financial disclosure reporting system, guiding NASA's legal team and its practice of law. Our second and final presentation is the Distinguished Public Service Medal. Today, we honor 11 in this category. Dr. James A. Coakley, Jr. is being honored for distinguished visionary service in atmospheric science research. Dr. Coakley is recognized worldwide as a pioneering scientist, and renowned research has made scientific contributions that have advanced the understanding of the role of aerosols, clouds, and radiation in the Earth's climate system. During his distinguished career, Dr. Coakley has authored numerous papers on aerosols, clouds, and the Earth radiation budget with regard to how they affect our climate. He is currently a professor of atmospheric sciences at Oregon State University and conducts research at the NASA Langley Research Center. Dr. John Gregory is being honored for sustained and exceptional leadership in integrating research and education in space science and engineering over several decades. Dr. Gregory has coupled a passion for education with his own noteworthy high-energy astrophysics and space environmental effects research and development experience to innovatively launch, design, build, fly, and analyze. This portfolio of programs uses the National Space Grant College Network for students to design and build flight hardware on their own initiative. These highly successful programs have touched thousands of students in all 50 states. He has established the NASA Academy in 1994, which has expanded to include robotics and propulsion. And he has provided intensive research experiences to hundreds of students, many of whom decide on careers with NASA. For the past 22 years, he has directed the NASA Alabama Space Grant Consortium that includes all research universities in the state, plus several community colleges, and the NASA Alabama Experimental Program to stimulate competitive research, leading these to national prominence. Mr. Thomas Hancock is being honored for exceptional dedication and professionalism in sharing NASA aerospace education opportunities with students and educators around the world. Mr. Hancock has had a notable career of 33 years. Through his role with the American Institute of Aeronautics and Astronautics, or AIAA, Mr. Hancock's distinguished service, technical credibility, and vision have provided exceptional leadership in support of the NASA's Office of Human Capital Academic Affairs Office. Through AIAA programs and numerous others, He has engaged multiple generations of aerospace engineers, beginning with the science, technology, engineering, and mathematics learning opportunities for K through 12 students by providing the tools and resources necessary for educators and students to take their understanding of aerospace to the next level. Mr. Hancock demonstrates, just a little more, Mr. Hancock demonstrates a level of aerospace and aeronautics excellence that has made a profound and indelible impact on NASA's education mission success. Dr. Bruce M. Jakosky is being honored for dedicated commitment and numerous contributions to NASA Mars missions, especially the MAVEN project, benefiting NASA and the world. Dr. Jakosky of the University of Colorado's Laboratory for Atmospheric and Space Physics has a long and distinguished career working on Mars missions since the Viking missions in the 1970s. And he continues to make extraordinary contributions to NASA's mission with the Mars Atmosphere and Volatile Evolution, or MAVEN mission. With MAVEN, he has set out on a journey to understand the role that the loss of atmosphere to space has played on the climate change that is inferred to have occurred over time on Mars. As the principal investigator, Dr. Jakosky has full responsibility for the performance of the mission, which was launched in November 2013. And the world awaits the scientific discoveries that MAVEN is poised to deliver upon arrival at Mars in September 2014. His leadership and the delivery of the launch of the MAVEN mission with full technical capability affirmed all public's confidence in NASA and set a high standards for performance of all. Dr. Hans J. Koenigsmann is being honored for exceptional success in developing commercial resupply services to the International Space Station. Dr. Koenigsmann has demonstrated exceptional leadership and ingenuity as the Vice President of Mission Assurance, as well as serving as the Launch Vehicle Chief Engineer for SpaceX. Specifically, he was instrumental in the ground-up development of SpaceX, a new commercial launch capability to resupply and return critical cargo to the International Space Station, or ISS. His unique skills and open customer relationships provide the continuity needed to ensure timely and cost-effective launch services during these times of change and anomaly. His commitment to understanding, resolving, and coordinating with NASA is key, and because of his experience, knowledge, expertise, insightfulness, and leadership, SpaceX is capable of supplying commercial resupply services to the ISS. Dr. Mason Peck is being honored for outstanding leadership of NASA technology policy and advocacy for technology development to deliver innovative solutions for NASA missions and the significant national needs. With a broad background in aerospace technology and nearly 20 years of experience in industry and academia, Dr. Peck infused cutting-edge technological innovations during his 2-year service as NASA's chief technologist. Serving the agency through the intergovernmental agreement with Cornell University, he documented, demonstrated, and communicated the societal impact of NASA's technology investments and led technology transfer and commercialization efforts. Over the years, Dr. Peck worked with NASA as an engineer on a variety of technology programs, served as a consultant with private industry, and authored 90 academic articles. Holding 17 US and European patents, he infused creativity into NASA missions, which benefited not only space technology programs, but the day-to-day lives of all Americans. Mr. Thomas Pearson, who is being recognized posthumously today, is being honored for distinguished service to NASA and the scientific community through the leadership of the SETI Institute, supporting basic research and education dealing with life in the universe. Mr. Pearson was the founder and chief executive officer of the Search for Extraterrestrial Intelligence Institute, a basic research organization that supports NASA research, programs in astronomy, planetary science, and astrobiology. Founded in 1984, the private, nonprofit organization has cooperated closely with NASA Ames Research Center in basic research, education, and mission operations. Mr. Pearson was instrumental in recruiting world-renowned scientists and engineers, and under his direction, the Institute administered over $275 million total in funded research. Mr. Pearson's legacy will live on in the Institute, which hosts the RINGS node for NASA's planetary data system and has a lead education role for the Stratospheric Observatory for Infrared Astronomy and Kepler missions. Mr. Matthew N. Ramsey is being honored for commitment, diligence, and superior service in the planning and execution of space launch systems, design analysis cycle, and configuration management. Mr. Ramsey's overall service and contribution to NASA programs and projects have profoundly impacted the success of the NASA mission. He has displayed exceptional quality, tireless service, and innovative vision as the Space Launch System, or SLS, program advances throughout the spacecraft vehicle program life cycle. He determined the Design Analysis Cycle, or DAC, execution strategy for SLS and set strategies for timing of vehicle and element analysis cycles to ensure all were defined and available. Without his leadership in this critical area, it is unlikely that the program would have advanced on schedule. Mr. Ramsey's appreciable contributions to SLS continue to have a significant influence on the program's ability to successfully meet stakeholder requirements, affordability objectives, and mission capabilities. Mr. William Shatner, who could not be with us here today, is being honored for outstanding generosity, education, and dedication to inspiring new generations of explorers around the world, and unwavering support for NASA and its missions of discovery. A lifelong advocate of space exploration and NASA, Mr. Shatner's long-standing relationship with NASA dates back to his portrayal of Captain James T. Kirk in the Star Trek series and films. It continued with visible public outreach efforts in 1979 surrounding the introduction of the Space Shuttle prototype and endures today. Most recently, he donated his valuable time and vocal skills to narrate a NASA documentary celebrating the 30th anniversary of the Space Shuttle program and honored the final flight of the shuttle by recreating his famous television introduction as the last wake-up call for STS-133. He often uses his Twitter account and his nearly 2 million followers to interact directly with NASA, voicing his support for the latest agency news and imagery. Dr. Edward C. Stone, who also could not be with us here today, is being honored for a lifetime of extraordinary scientific achievement and outstanding leadership of space science missions, as well as his exemplary sharing of the exciting results with the public. An internationally known physicist and California Institute of Technology professor, Dr. Stone has served as project scientist for the Voyager program from 1972 to the present. The Voyager 1 spacecraft launched in 1977 and now is more than 11 billion miles from Earth. It recently became the first man-made object to enter interstellar space. Dr. Stone's leadership of this mission, as well as his numerous contributions to both Earth and space science, make him fully deserving of NASA's highest civilian honor. Highlights of his decades of leadership include Galileo's 5-year orbital mission to Jupiter, the launch of the Cassini spacecraft to Saturn, and the launch of the Mars Global Surveyor and a new generation of Earth science satellites, as well as a successful Mars Pathfinder landing in 1997. Our final honoree today is Mr. Patrick Wiggins. Mr. Wiggins is being honored for superior individual dedication to community and scientific engagement as NASA's prolific Solar System Ambassador. Mr. Wiggins joined the NASA Solar Systems Ambassador, or SSA program, in January 2002, shortly before retiring from the Hansen Planetarium following 26 years of service. Over the past 12 years, he has conducted over 1,050 events, averaging 88 events per year, well over the 4 events per year that are asked of volunteers. With a background in astronomy and a solid reputation for public engagement, Mr. Wiggins tirelessly travels across the state of Utah, performing outreach, giving educational talks to students, and regularly provides updates on NASA's space exploratory efforts to local media. His superior dedication and volunteer efforts have built a positive reputation for not only the SSA program, but also those of NASA. Let's give all of our distinguished honorees another round of applause for their outstanding contributions to NASA. I would also like to extend our special appreciation to Mr. Bolin, Mr. Lightfoot, and Mr. Baruki, the Military District of Washington's Joint Armed Forces Color Guard, especially Ms. Thomas, and the ceremony volunteers for their contributions in making today's ceremony a success. The NASA Agency Honor Awards program would not have been made possible without the dedication and contributions of the Incentive Awards Board expert panels, Center Review Boards, and the NASA Awards community. The agency also wishes to recognize our special guests, representatives from the Smithsonian National Air and Space Museum and the NASA Office of Education, as well as STEM students from the McKinley Tech High School, Central High School in Prince George's County, and Anacostia High School, and the NASA STEM ambassadors. May you continue to strive to reach new heights and inspire future generations of space explorers. To the extraordinary honorees, we thank you for participating in today's event, and we wish you much continued success in your future endeavors. Thank you.